Hello, welcome to Tennessee's at-home learning series for math. Today's lesson is for all our 8th graders out there, though all students are welcome to tune in. This lesson is the 16th in our series. My name is Candace Thompson, and I'm an 8th grade math teacher at Oakland Middle School in the Rutherford County School System. I'm so excited to be your teacher for this lesson today. Welcome to my virtual classroom. If you didn't see our previous lesson, you can find it on the Tennessee Department of Education's website that I have pulled up here. You will want to scroll down to Math Grade 8 to find the lesson plans, as well as the student packet that will have the independent practice available as you complete today's lesson. So you may have heard about the name Pythagorean Theorem that we're going to work with today. But did you know about the theorem's namesake? Around 2,500 years ago, a Greek philosopher named Pythagoras lived on an island called Samos in the North Aegean Sea. We don't have too many details about his early life, but at some point, he traveled around and ended up in southern Italy, where he founded a school. Pythagoras was credited with many mathematical and scientific discoveries, and his work influenced other scientists you may have heard of, such as Nicholas Copernicus and Isaac Newton. Today, we're going to explore the Pythagorean theorem. There's historical evidence that the concept behind the theorem was known before Pythagoras' time, but he formalized it in his way. So go ahead and start with writing down this in your notes for me. In a right triangle, the square of the length of the hypotenuse, C, is equal to the sum of the squares of the lengths of the legs, A and B. In other words, A squared plus B squared equals C squared. Did you get that written down? Did you notice a couple vocabulary words that we might need to explore? Let's look at this picture of a right triangle and explore the vocabulary together. You can sketch it along with my drawing here. What do you notice about the hypotenuse? What do you notice about the hypotenuse? It's the longest of the three sides, and it's across from the right angle in the triangle. The other sides are called legs. We can label one of them A and one of them B when we are working on problems. Now that you've got the vocabulary and model, let's try some application problems together. Let's start with some triangles with discussing side lengths. Sketch this example here. So we've got a leg of 7 inches. I'm just going to put out to this side leg A. We've got a leg of 24 inches. I'm just going to put out here leg B, and we are solving for the hypotenuse C. So now that everything is labeled, we need to decide if the missing side length is a leg or hypotenuse. Let's look at the diagram and refer back to the notes you made in the beginning. If you said that the missing side length is a hypotenuse, then you're correct. It is the side opposite the right angle. What are the other two lengths, 7 and 24? Again, they're leg lengths, leg A and leg B. Does it matter which one is A and which one is B? No, it really doesn't matter. I just labeled this A, I labeled this B, but you could have done that opposite. It doesn't matter because we're adding the squares of the sides, and addition is a commutative operation, meaning we can add in any order. From the order of operations, you will also remember that we multiply first, which is what we are doing when we square numbers. We know that the calculation can be made using the algebraic equation, a squared plus b squared equals c squared, where a and b are leg lengths and c is the hypotenuse length. So we can substitute in the equation and solve like this. Right along with me. So we have 7 squared plus 24 squared equals c squared. Squaring the numbers means to multiply the number by itself. By order of operations, we do this first before we add the terms, like this. So 7 squared is equal to 49. 24 squared is equal to 576, and that's equal to c squared. Now we can add these together. So we have 625 equals c squared. To solve it from here, you must take the square root of each side. Remember that taking the square root of a number is finding the number that you can multiply by itself to get the number you started with. Sometimes this is not a whole number, so you may want your calculator or calculator app to help you. Really quick, I'm going to show you first. I want you to know that I'm using a student calculator here that my students would have used, and I'm going to show you how to put the square root function in there. However, I realize that you probably may not have this available to you. So just a reminder, the calculator app, if you have it open like this, you're going to want to make sure your portrait orientation lock is off. And then when you turn it landscape and you're trying to take the square root. So for example, we want to take, let me see if this helps. There we go. Still a little bit of a glare, but if you want to take the square root of 625, you're going to click 625, and then we're going to take the square root. You want to click this little one that has a 2. So take the square root of that, and we get 25. So just know that this is an option for you if you don't have a calculator available. I'm going to be using the student calculator that my students would have used. So I'm going to type in the square root of 625, and we get 25. So C is equal to 25. So we see that the length of the hypotenuse is 25 inches. Does that make sense given the diagram and the definition of the hypotenuse? It seems to, because the value is larger than the other two measurements, and the missing side length is the hypotenuse. So if I were to do my work and get a number that is less than, these two numbers, then I know that I've made an error because the hypotenuse has got to be the largest measurement. Now let's try another example. Sketch this model and label it with me. Which side is missing this time, the hypotenuse or a leg? If you said leg, you are absolutely correct. Remember, this missing link can be labeled as A or B. Which measurement is the hypotenuse? If you said 15, you are correct again. If it is the side opposite the right angle. So we can substitute into the equation to solve like this, right along with me. So we're going to always start with our Pythagorean theorem first. A squared plus b squared equals c squared. I'm going to plug in 13 for A, but remember it doesn't matter. I could leave A as A and plug in 13 for B. So I have 13 squared plus b squared, and then for C, I'm going to plug in 15. So I have 169 plus b squared equals 225. And from here, it's a little bit different since I'm solving for the leg. I'm going to have to subtract this value to get it to the other side of the equal sign so that I'm able to solve for b. So I'm going to subtract from both sides, and I get that b squared is equal to 56. To solve it from here, you must take the square root of each side. You will want to use your calculator or calculator app to help you and round your answer to the nearest tenth. So I'm going to put in my calculator the square root. Let me zoom this up. I'm going to put in my calculator the square root of 56. And I get this number here. So we wanted to we want to get a decimal expansion, and we're going to round that to the nearest tenth. So if you're, for some reason, working with a calculator like this, you're just going to push this button here to get the decimal expansion. And here's our number. Now, what would our answer be rounded to the nearest tenth? Good. It would be 7.5. So the missing side length rounded to the nearest tenth is 7.5 yards. A painter has an 8-foot ladder that is being used to paint a room in a house. For safety reasons, the ladder must be placed at least 3 feet away from the base of the wall. To the nearest tenth of a foot, how high will the ladder reach on the wall? Assume that the wall and the floor meet at a right angle. Did you sketch a picture? Does your sketch look something like this? So we need to find the missing side length, which is how high up on the wall that the ladder will come. In this case, we need a leg length. So we can solve it this way. Follow along with me. I'm going to start with my formula, a squared plus b squared equals c squared. This time I'm going to leave a blank. I'm going to plug in 3 for a leg. So 3 for b, which I didn't do here. And then 8 for c. So I have a squared plus 9 equals 64. And then I'm going to subtract 9 from both sides. So I have a squared equals 55. To solve it from here, you must take the square root of each side. You will want your calculator or a calculator app to help you. Round your answer to the nearest tenth. So I'm going to use my student calculator here. So the square root of 55 and rounded to the nearest tenth, that would be 7.4. So the missing side length rounded to the nearest tenth is 7.4 feet. Let's move this up one more level and see what the Pythagorean theorem looks like in 3 dimensions. I'll read the problem out loud and you follow along and sketch the model. Okay. Tina ordered a replacement part for her desk. It was shipped in a box that measures 4 inches by 4 inches by 14 inches. What is the greatest length in whole inches that the part could have been? Let's look at a diagram of this box. Now, this one can be tricky because we have to think what measurements look like inside of a shipping box. In this case, we want to find a measurement of the length labeled R. So we're looking at this measurement here because that's the corner to corner length that would give us the maximum size we could fit in the box. So it's going to give me corner to corner length here. That's going to tell me the maximum, how, the biggest that an object can be. But first we need to find the measurement of the length labeled S in the diagram. Because we have the dimensions of the box, we can figure out the length of S using the Pythagorean theorem. Now, is S going to be a hypotenuse or a leg first? Is S going to be a hypotenuse or a leg first? Did you see it? If S is our missing length, it is a hypotenuse of the triangle formed by the base of the box. So I have this leg here, and I have this leg here, and S is going to be the diagonal or the hypotenuse. So the 2 leg lengths are, so this leg length is going to be just the exact same as this, and they say this is 4. So I have a leg length of 4 inches. This leg length is 14 inches, and I'm solving for the hypotenuse S. Okay, so follow along with me, and let's figure out what that length is. So I'm going to start up here. A squared plus b squared equals c squared. I've got a leg length of 4, a leg length of 14. 16 plus 196 equals c squared. 212 equals c squared. To solve it from here, you're going to take the square root of both sides. You're going to want to use your calculator or your calculator app to help you and round your answer to the nearest hundredth. So I'm going to use my calculator here take the square root of 212, round it to the nearest hundredth. So I'm looking here, I'll look next door. So I'm going to leave it as 14 and 56 hundredths. Now that we have the side length S, we need to find the value of R. But this time, what triangle are we looking at? Let's see. Did you see it? I'll trace it for you. So we have a leg here. Okay. And now we have a leg here. And then R is going to be the hypotenuse. So in this triangle, we have a leg, and this is going to be 4. I know that because over here, this measurement's equivalent to that, and it's 4. So I've got, I'm going to draw an arrow here. That is going to be 4 inches, and then I just discovered that S was 14 and 56 hundredths, so 14 and 56, 14.56 inches here. And now I'm going to solve for R. Follow along with me. So we're going to do A squared plus B squared equals C squared. I'm going to plug in 4 for A, 14 and 56 hundredths for B, and solve for C. So I get 16 plus 212, 212 equals C squared. 228, it would help if you could see. 228 equals C squared. From here, you're going to use your calculator or calculator app to take the square root. So I'm going to do the square root of 228. And we are going to round that to the nearest tenth. So I look here. I look next door, that's going to move that 0 up to a 1. So C equals 15.1, or R in this case equals 15.1 inches. Now, let's see how to answer the original question. It says, let's highlight what it says. What is the greatest length in whole inches that could have been? What's the greatest length in whole inches? So in this case, to respond to the question, we would say that the part that could have been at most 15 inches long if we packed it on the diagonal of the interior of the box. Great work. Let's practice a couple more. I'll walk you through another example. Look at the diagram and sketch on your own paper. All right. Which side length is missing, the hypotenuse or a leg length? Right, the hypotenuse is missing, or what the Pythagorean theorem calls C, because it's the side opposite the right angle. And it appears to be the longest side length. The other measurements are legs, 10 feet and 24 feet. We are ready to substitute in and solve. Follow along with me. So we have A squared plus B squared equals C squared. 10 is a leg, so we'll plug that in. 24 is a leg, so we'll plug that in. From here we have 100 plus 576 equals C squared. 676 equals C squared. To solve it from here, we're going to take the square root of each side. So right now is when you're going to want to use your calculator or your calculator app. So I'm going to plug in the square root of 676, and I get 26. So I have C equals 26. So in this case, we calculate that the length of the hypotenuse of the right angle triangle is exactly 26 feet. Now let's look at one more together. Let's work on another shipping box problem. I'll read it aloud and you follow along. Make a sketch to model the problem. Mr. Luna wants to ship a fishing rod that is 42 inches long to a customer. He has a box that measures 10 inches by 10 inches by 40 inches. Will the fishing rod fit inside the box? Here's a sketch of the problem. First, let's find the length of the diagonal across the bottom of the box. So we're talking about this length here, the diagonal of the bottom of the box. Is this diagonal length a hypotenuse or a leg length? Right, it's the hypotenuse that we are trying to find first. What are the lengths of the two legs? Right, the lengths are 40 inches, that's one leg, and then this leg over here is going to be 10 inches because it's equivalent to this side. It says the width is 10 inches, so this is 10 inches. I'll get you started and give you time to work. I'll substitute in the leg lengths first. So I have a squared plus b squared equals c squared. 40 squared plus 10 squared equals c squared. Now you take it from here and find the diagonal length. Here's what I got. How about you? So I've got 1600 plus 100 equals c squared. 1700 equals c squared. And then we're going to take the square root of both sides. So the square root of 1700. And here is what we get. 41 and 23 hundredths. Now we want to use this length to find the measure of the inside diagonal. So we're looking at this here. I'm going to highlight it in, let's do purple. This is what we're trying to find now. I'll get you started again and see if you can answer the question about whether or not the fishing rod that's 24 inches will fit in the box. I'll substitute the leg lengths first. Don't forget that one leg in this triangle is the height of the box, which is 10 inches. And the other leg is the length we just calculated here, which would be 41.23 inches. So we have a squared plus b squared equals c squared. 10 squared plus 41.23 squared equals c squared. Now you see if you can take it from here to find the diagonal length. Here's what I got. How about you? 100 plus 1700 equals c squared. 1800 equals c squared. And then the square root would be 42.4. So does the fishing rod fit? Yes, the box is big enough to hold the rod. Great work. Here's a simple diagram. Take a look and make a sketch to help you think about it. Decide if the missing side length is the hypotenuse or a leg length. Then use the Pythagorean theorem to find the length of the missing side. Round your answer to the nearest tenth if needed. All right, how'd you do? If you calculated that the missing side length is 50 feet, then you are correct. The length missing was the hypotenuse. Let me show you my calculations. Check yours against mine. So I'm going to start with our Pythagorean theorem. I'm going to plug in our leg lengths here and simplify those. I'm going to take the square root of both sides and get 50 equals C. Great work. Here's another example. Look at your diagram and make a sketch on your own paper. What side length is missing, the hypotenuse or the leg length? Right, the hypotenuse is missing, or what the Pythagorean theorem calls C, because it's opposite the right angle, and it appears to be the longest side length. The other two measurements are legs. We are ready to substitute in and solve. Follow along with me. So I'm going to, of course, start with my formula. I'm going to plug in my leg lengths. And I have 2,704 equals C squared. Now to solve it from here, as you guys know, you're going to take the square root of each side. So make sure that for this part, you use your calculator or your calculator app. And when you do that, we have C equals 52. So in this case, we calculate the length of the hypotenuse on the right angle is exactly 52 centimeters long. All right, how are you feeling about using the Pythagorean theorem to find one missing side length? I hope your confidence has been built each time that we've tried a problem. The Pythagorean theorem has many applications in other settings, and we will look at some of those in the next few lessons. After this lesson, you will have some problems to practice on your own, and I have shown you where on our website that I'm showing you now to find those. Good luck and do your best. I really enjoyed exploring the Pythagorean theorem to find missing side lengths in a right angle triangle with you today. Thank you so much for inviting me into your home. I look forward to seeing you in our next Tennessee's at Home Learning Series. Goodbye.